In today's video, we'll be discussing about mathematics, paper 4, mechanics, 2023, October-November variant is 41 and the subject code is 9709. Particle of mass 1.6 kg is projected with a speed of 20 meter per second. So its initial speed u is equal to 20 meter per second up a line of the greatest slope of a smooth plane. Smooth plane, that means there is no effect of friction, that is mu r. Inclined to the horizontal at an angle alpha, where tan alpha is given. So as we have given the value of tan alpha, so we need to calculate sin alpha and cos alpha because we need this later. Then use an energy method to find the distance the particle moves up the plane before coming to instantaneous rest. So we need to use energy method, that means the energy at the start of the journey and the energy at the end of the journey, and we need to find the distance the particles move before coming instantaneously to rest. At rest we know that velocity is 0, so the final velocity is 0. So if we compare, we know that initially as the particle starts to move, it has a kinetic energy, but since it starts from the bottom of the slope, so it has 0 vertical height. So the gravitational potential energy is 0 while it has some kinetic energy. Then as it moves to the top of the slope where its final velocity is 0, therefore kinetic energy is 0. So we need to find the height at this point. So the height would be mass into gravitational force into height. So the height comes equal to 20 meter. Now it mentions in the question that use an energy method to find the distance the particles move up the plane. So what distance the particle moves, actually find the vertical height, but the distance the particle moves is this distance that the particle covers or particle moves. So how to find this distance? We know the vertical height and we know the angle. So we know that sin alpha is equal to opposite by adjacent. So first of all we need to find the value of alpha, then sin alpha is equal to opposite by adjacent. So the distance comes to be that the distance the particle covers is this distance, comes to be 100 by 3 as our final answer. A particle of mass 2.4 kg is held in equilibrium. So the particle is in equilibrium, that means the resultant force is 0 by two light inextensible strings, one of which is attached to a point A, that is at this point A, and the other is attached to a point B. The string makes an angle of 35 degree, that means as it is first referred as A, so the angle of A with the string the horizontal is 35 degree and the angle of B with the horizontal is 40 degree to the horizontal. Find the tension in each of these two strings. So to find the tension we need to calculate, actually we can see that since the two strings are different, so the value of tension for the two strings is also different. So we refer the tension for A as T1 and the tension for B as T2. Then as they act at an angle, so we need to find their horizontal and vertical component. That is, the horizontal component would be cos 35 and the vertical component is sin 35, and T1 sin 35 and T1 cos 35. Similarly, T2 cos 40 would be the horizontal component and the vertical component is T2 sin 40. And we have to always remember that since the particle is at rest and the particle has some mass that is given, therefore it experiences a force due to the Earth's gravity, that is 2.4 g, which is the gravitational field strength. So after equating the horizontal components, that is this components, and the vertical components, that is T sin 35 plus T2 sin 40 is equal to 2.4 g. Since the object is at equilibrium, after equating this we calculate a value of T2, that is 20.36, and T1, that is 19.03 as our final answer. 3. The diagram shows the velocity time graph for the motion of a bus. The bus starts from rest and accelerates uniformly for 8 seconds until it reaches a speed of 12.6 meter per second. So it accelerates until it reaches a speed of 12.6 meter per second, and the acceleration is uniform acceleration. Then the bus maintains the speed for 40 seconds. So the bus maintains the speed for 40 seconds. It then decelerates uniformly in two stages. So between 48 to 62 seconds, the bus decelerates at a meter per second square. Now you have to remember that the deceleration is a meter per second square, that is d is referred as a meter per second square, and between 62 to 70 seconds it decelerates as 2a meter per second square. That means at this range the deceleration is 2a, or 2d is equal to 2a until it comes to rest. Find the distance covered by the bus in the first 8 seconds. So we know that the distance is the area under the velocity time graph, and we know the height and the base. So the area of the triangle would be half base into height to calculate the distance in the first 8 seconds. Then we need to find the value of a. So if we see clearly that a is referred to as this point, that is deceleration is referred as a. So first of all we need to find the value of deceleration, then equate this to a to find our answer. So the formula for deceleration is, since it is deceleration and not negative acceleration, so we have to give our answer as positive since it is a deceleration. So deceleration would be that initial velocity minus final velocity, that is v, initial minus final by total time. So initial velocity, that is 12.6, minus final velocity, that is v, by 62 minus 48. So this is a, or d. So the deceleration comes to be, or after solving it comes to be, v is equal to 12.6 minus 14a. So we get our first expression, and for the second expression, that means this deceleration, that is 2d, is referred as 2m. So the formula is initial minus final velocity by total time. Since it is deceleration and we have to give our answer as positive, thus we have to take initial velocity. Since initial velocity has a higher value than final velocity, so the answer should be positive. So 2a minus is equal to initial velocity minus final velocity by total time, that is 70 minus 62. After calculating we get our second expression. Then we solve it simultaneously to find the value of a, that is positive, or positive deceleration, that is 0.42 meter per second square, as our final answer. We need to find the average speed for the bus for the whole journey. To find the average speed, we need to find the total distance traveled, then divide it by total time to calculate the average speed. So the total distance, first of all, to calculate the total distance traveled, we don't know this value of v, but we know the expression and the value of a. So we put the value of a in any of this expression to find the value of v, that is the value of v comes to be 6.72, that is this v. So 6.72. Then to find the area of the area under the graph, the area would be first of all the area under the triangle, that is half into base into height. Then area of the rectangle, that is base into height. Then area of the trapezium, half into sum of two parallel sides into height, that is this parallel side and this parallel side minus, that is the value of this parallel side, that is 12.6, plus 6.72 into height, that is 62 minus 48. Then the area of the second last triangle would be half into base into height, that is this base, and the height is, that is 6.72, that is that I have calculated earlier. After solving, this is the total distance, that is from the graph, this graph. So after solving we get the total distance as 716.52 meter. So the average speed, that is the total distance traveled, that is 716.52 by total time, and the total time for this is 70. So after solving we get our answer as 10.236, or correct to 4 significant figure it would be 10.24 meter per second as our final answer of speed. In question number 4, two particles P and Q are of mass 6 kg and 2 kg respectively. So as P is mentioned first, so its mass is 6 kg and the mass of Q is 2 kg respectively, lie at rest at 12.5 meter apart on a rough horizontal plane. So they are 12.5 meter apart. So the distance between these two particles is 12.5 meter and is on a rough plane. That means there is an effect of friction, that is mu r. The coefficient of friction between each particle and the plane is 0.4. So we have given the value of mu, that is 0.4. Particle P is projected towards Q with a speed of 20 meter per second. So P moves towards Q with a speed of 20 meter per second. That means its initial speed is 20 meter per second. Show that the speed of P immediately before collision with Q is 10√3. So we need to find the speed of P immediately before collision with Q, that means at this point. So to find the speed of P at this point, we know the initial speed. So we can use the equation v square minus u square is equal to 2as. We know the initial speed, we know the distance, but we need to find the acceleration. So what would be the acceleration? Since there is no forward force acting on the object, as there is no forward force mentioned here, but we know that there is an effect of friction. That means the only force acting on the object is the backward resistive force, that is mu r. So forward force is 0 minus mu r is equal to mass into acceleration. So after calculating, acceleration comes to be negative 4 meter per second square. So we know the value of acceleration and we know the value of u and s. So v square minus u square is equal to 2as. So v comes to be 10√3 as given. P and Q coalesce. That means coalesce means that P and Q stick together to form a particle R. So P and Q together form particle R after collision. Find the loss in kinetic energy due to collision. So to find the loss in kinetic energy, we need to find the initial and the final kinetic energy and find the loss. So the initial kinetic energy would be, since we know that the particle Q is initially at rest, that is given at rest, so Q is at rest, so initial kinetic energy is 0, while for P the initial kinetic energy is half mv square. And you have to remember that though we are talking about the initial kinetic energy, it means that the kinetic energy just before collision and the kinetic energy and the final kinetic energy would be kinetic energy after collision. It does not refer the initial kinetic energy at which the P starts. It is the kinetic energy before collision. So the initial kinetic energy of P before collision is half mv square and its kinetic energy or the speed before collision is 10√3 that we have calculated earlier. So before collision its speed is 10√3. So the kinetic energy half mv square. This comes to be 900 joules. And the final kinetic energy, that is final kinetic energy after collision. So as we can see that the kinetic energy of Q is initially 0, while we know the speed of P before collision. So the kinetic energy before collision is half mv square, that's 900 joule. Then after collision, the total particles have a combined mass, or let's first to find the kinetic energy after collision, that is the kinetic energy of P and Q after collision. Since P and Q coalesce, so we need to find the only one speed to find the kinetic energy, but we don't know the final speed, that is the final v. So the final speed, to find the value of final speed, we know that momentum before collision is equal to the momentum after collision. So momentum before collision, that is mass into velocity of P, and Q is at rest, so its mass into velocity is 0, is equal to the final mass into velocity. And since P and Q coalesce, that means we have to take their combined mass, that is the mass of P is 6 and the mass of Q is 2 as given, that is 6 and 2. So and we need to find the final velocity to find the final kinetic energy. So mass into velocity, that is the mass is 6 into plus 2, that is 8, and the velocity, that is v. So after calculating we get the value of v, that is 7.5 root 3. Then the kinetic energy after collision would be half mv square, and since the particle is squareless, so we have to calculate just one kinetic energy, that is half mv square, that is the total m and the total speed square. So the final kinetic energy comes to be 6.7 or 675, just 675 joules. So the loss in kinetic energy is equal to initial kinetic energy minus final kinetic energy, that is 225 meter per second. Coefficient of friction between particle r and the plane is 0.4. So the value of mu is 0.4. And what is particle r? So as we know that particle p and q coalesce, that means stick together to form particle r. That means p and q stick together to form particle r. P has a mass of 6, q has a mass of 2. So in total the particle r has a mass of 8, that is the total mass, and the total speed is v is equal to, that we have calculated, is 7.5 root 3, 7.5 root 3 meter per second for particle r. So to find the distance traveled by particle r before coming to rest, so we need to find the distance traveled by particle r before coming to rest, that means before coming to a speed that is 0. So to find the distance traveled by particle r, we know that v square minus u square is equal to 2as, that is this formula, and we know that before coming to rest, that means the final speed is 0, and we know the initial speed, that is 7 root 3 and 2as. So we need to find the value of distance. So to calculate the value of distance, we know all the variables except we don't know the acceleration. So we need to first find the value of acceleration. So what would be the acceleration? Since particle r is moving on its own and there is no forward forces acting, so the only force acting on the particle r is due to the friction that is given, that is mu r. So the forward force is 0 minus backward force, that is mu r. We know the value of mu, and r would be the vertical resistive force. So r is equal to 8g, since there is no other force, so r is equal to 8g. So mu r is equal to mass into acceleration. So we know the value of mass, that is the mass of p, that is 6, and the mass of q, that is 2. In total the mass of r is 8. So mass of r is 8. We need to find the value of acceleration. So acceleration is negative 4 meter per second square. Since there is no forward force, the object is decelerating, so the acceleration is negative. Then after using the equation v square minus u square is equal to 2as, we find the final distance, that is 20, or the total distance traveled by r before coming to rest is 21.1 meter. Question number 5. The diagram shows a particle A. So the particle A of mass 1.2 kg, that is acting vertical, that is its weight is acting vertically downwards. So 1.2 g, where g is the gravitational field strength, lies on a plane of an inclined plane inclined at an angle of 40 degree to the horizontal, and the particle p of mass 1.6 kg, since its mass is 1.6 kg, so its downwards weight is 16g, 1.6 g, which lies on the plane inclined at an angle of 50 degree to the horizontal. So this angle is 50 degree. Then the particles are connected by light in extensible strings. So the string is inextensible, that means it is difficult to break, which passes over a smooth pulley, that means there is no friction about the pulley P, that is this pulley fixed at the top of the plane. The part AP and BP, that is AP and BP of the string, is taut and parallel to the line of the greatest slope of the respective plane. The two planes are half, that means in both the planes there is an effect of friction, that is mu r, with the same coefficient of friction, that is mu. So the coefficient of friction is same between the particles and the plane. Find the value of mu for which the system is in limiting equilibrium. Since the system is in limiting equilibrium, that means the system is about to move, that means we should consider the effect of friction in this system, since the particles are about to move. And for the system, we can see that there is not clearly stated that which particle would move up and which particle would move down. As they are in limiting equilibrium, that means they are about to move. So which particle is about to move up and which particle is about to move down? So we know the weight of B is 1.6 g, and for the weight of A is 1.2 g, and they are at the inclined plane, so we need to find their horizontal and the vertical component of forces. That is 1.6 g cos 50, 1.6 g sin 50, where the angle is 15, then the angle is 40, so 1.2 g cos 40, 1.2 g sin 40. Then if you compare this, the forces that are parallel to the or their component of weight that are parallel to the plane, we can see that the value of 1.6 g sin 50 is much higher than 1.2 g sin 40. So as this component is higher, that means the weight of B is higher, so B would continue to move down. Since its weight is higher, so it would move down, and its weight is lower, so it would move up. That means the system it would move in such a way that B would move down and A would move up. Then, as we know that particle B is moving down, therefore friction acts in the opposite direction to the motion. That means since the particle is moving down, so the friction should act upwards. And for particle A, since the particle A is moving upwards, so the friction acts in the opposite direction of motion, so the friction would act downwards, and we know the friction, that is mu r, where r is equal to the vertical forces. Vertical forces, or r is the resistive force that is equal to the vertical forces. So we know that which particles move in which direction. Now the forward force, that is for particle B, the forward force, that is 1.6 g sin 50, minus backward force, that is mu r, is equal minus backward force minus also the tension force. Since the particles are at the same string, so the value of tension should be the same, that is T. So forward force, that is 1.6 g sin 50, minus backward force, that is T, minus mu r, is equal to mass into acceleration. And since the objects are about to move and the objects are not moving, or there is no initial velocity, so the acceleration is 0. And for particle A, the forward force is T, since it is moving in this direction, so the forward force is T minus 1.6 g sin 40 minus mu r is equal to mass into acceleration, and the acceleration is 0. Since they are at equilibrium, so acceleration is 0. Since they are at equilibrium, so acceleration is 0, but as they are limiting equilibrium, so we have to consider the effect of friction, that is mu r. So after substituting these values, we get two expressions as equation 1 and equation 2. Then we just need to solve it simultaneously to find the value of mu as our answer. Question number 6. A car has a mass of 1300 kg and is moving on the straight road. On the horizontal section of the road, the car has a constant speed of 30 meters per second. Since the car is moving at a constant speed, and at constant speed we know that acceleration is 0, so the driving force is equal to the resistive force, and there is a constant force of 650 Newton resisting the motion, that is the resistive force R. Calculated in kilowatt, the power developed by the engine of the car. Since we know that the object is moving at a constant speed, therefore driving force is equal to the resistive force, and we know that power is equal to driving force into velocity. So driving force is equal to power by velocity, and the velocity is 30 meters per second. So after substituting the value, then we know that since the object is moving at a constant speed, so driving force is equal to resistive force, and we know the value of resistive force. After calculation, we get the value of P as 19.5 kilowatt, as mentioned in the question that we have to give our answer in kilowatt. Given that this power is suddenly increased by 9 kilowatt, so as the power is increased by 9 kilowatt, so initially the power is 19.5 kilowatt, and after it is increased by 9 kilowatt, the power comes to be 28.5 kilowatt. So we know the power, and we need to find the final instantaneous acceleration. So we need to find the value of acceleration. So we know the value of power, and we know that driving force minus resistive force is equal to mass into acceleration. So driving force, as we know that power is equal to driving force into velocity, so driving force is equal to power by velocity. That is, power by velocity is equal to the driving force. So the driving force, that is power, that is 28.5 into 10 to the power 3 watt by velocity. Since it is mentioned clearly about instantaneous acceleration, and it is mentioned about instantaneous acceleration, and we have not given a further detail about velocity, so we have to just consider the instantaneous velocity that is given earlier, that is 30 meter per second. So power by instantaneous velocity, though it is mentioned that initially it is at a constant velocity, that is 30 meter per second, but there is no other velocity given, and since it mentions clearly about instantaneous velocity, that means at this point or at that instant. So at that instant it has only a velocity of 30 meter per second. So power by velocity is the driving force minus resistive force, that is 650, that is constant. 650 is constant resistive force, is equal to mass into acceleration. The mass is 1300 kg or 1300 into acceleration, so the acceleration comes to be 3 by 13 meter per second square as our final answer. The section of the road inclined at an angle of sine inverse of 0.8 degree to the horizontal, the resistance to motion of the curve. So first of all, we have to remember that the road is inclined. So the particle is now on an inclined plane, that is at an angle of sine inverse of 0.8 degree to the horizontal. So since we have given the sine inverse of 0.8 degree, that means we have given the value of angle. So the sine theta would be, theta is sine inverse of sine inverse of 0.8. So sine theta is equal to, that means we press the sine at this side, so sine theta is equal to 0.8. There is 0. It is 0.08, so there would be a 0.08. So sine theta would be 0.08. So sine theta would be 0.08. We know the value of sine theta. The value of cos theta would be, after calculating, it comes to be 0.9967. So now the resistance to motion of the car is 1000 plus 20 v. So resistance to motion is 1000 plus 20 v. There is the value of resistance when the car is moving at a speed of v meter per second. The car travels downwards. So it is clearly mentioned in the question that the car is traveling downwards. So the resistive force should act upwards, that is 1000 plus 20 v on the section of the road at a constant speed with which the car is working at 11.5 kilowatt. So the car has a constant speed and its power is given as 11.5 kilowatt. So we have given the value of speed and the value of constant power. So we know that the driving force is equal to power by velocity, that is 11.5 into 10 to the power 3. Since it is kilowatt, so 11.5 into 10 to the power 3 by velocity, and we need to find the constant speed. That means for a constant speed acceleration is 0, so mass into acceleration is 0. That means drive the forward force is equal to the resistive force. So the forward force is, after calculating the horizontal and the vertical component of forces, the forward force is driving force, that is the driving force df plus the downward component of weight is equal to the upward force, that is the only upward force acting on the particle is the resistive force, and we have given the value of resistive force. So after calculating, we need to find the constant speed. So after calculating, the constant speed comes to be 25 meter per second as our final answer, and we also get our answer as negative 23. But since we know that since the object is moving downwards, so its speed should obviously increase. Since the object is moving downwards, so its speed should obviously increase. So we should get a value of positive speed and not a negative speed. So negative value is inadmissible or not in range or not acceptable. 7. A particle moves in a straight line starting from point O before coming to instantaneous rest. At rest, velocity is 0. That means it comes to instantaneous rest at velocity is equal to 0. Instantaneous rest at point x. So it comes to rest at point x and it starts from point O. So at the time t seconds after leaving O, the velocity is v meter per second for the particle as given. So here we have given some value of speed or the equation for speed and some speed time. So where k is a constant, it is given that there is no instantaneous change in velocity at t is equal to 8. It is a very important point. It mentions about there is no instantaneous change in speed at time t is equal to 8. And we know that time t is equal to 8 at this instant. Also time t is equal to 8 at this instant. That means between these two instants there is no change in speed. So as there is no change in speed and we need to calculate the distance ox, that is the total distance that particle covers. So initially it is mentioned that there is no instantaneous change in speed. That means the speed at this instant at time t is equal to 8 is equal to the speed at this instant at time t is equal to 8. So first of all, to calculate the distance, we can calculate the first two distances easily. But first of all, we need to find or we should calculate the value of k since we have given the information. So what would be the value of k? Since there is no instantaneous change in velocity, that means the velocity at time t is equal to 8 at this instant would be, after substituting the value of t, that is t is equal to 8, in this equation, we get the velocity as 23.4 meter per second. So we know that there is no instantaneous change in speed. That means the speed at this instant is equal to the speed at this instant. So at the speed at this instant would be 23.4 at time t is equal to 8. So velocity is 23.4, time t is equal to 8. We need to find the value of constant k. After calculating at time t is equal to 8 and v is equal to 23.4, we get the value of k from this last equation as negative 1 by 5. As we know the value of k, so we can just substitute the value of time to find the velocity at this instant or the distance at this instant. So now we need to calculate the total distance. So what would be the total distance ox? So the first distance would be from the first equation. We have given the velocity. So integrating velocity, we would get the distance. We know the velocity. So s would be integrating velocity between time t is equal to 2 to time t is equal to 0. That is this range. So integrating velocity, that is 7.2. And since we have to integrate this, so 7.2, after integrating we should give a t cube and then divide by the power, that is cube. So we have completed the integration. Now we have to just substitute the value to find our first distance. That is, after integrating we get this expression as shown. Then after substituting the value, that is 2 and 0, we get the distance, that is our first distance, as 96.5, 96 by 5. Then to calculate the second distance, we need to integrate this equation between time t is equal to 8 to time t is equal to 2. So integrating this equation, 30.6 t minus 0.9 t square divided by the power, that is 2. After substituting the value, we calculate the final distance, that is the second distance for the second interval is 156.6 as the second distance. Then the last distance would be, to calculate this distance, we know the lower limit but we don't know the upper limit. So what should be the upper limit? It is clearly mentioned in the question that we have to find the total distance before the particle comes instantaneously to rest at point x. That means at point x or at the end point, the particle comes instantaneously to rest. That means at the end point, the velocity should be 0 since the particle comes to instantaneous rest. That means at the end point the velocity is 0 or the final velocity is 0. So we equate the velocity to 0. We know the value of k that we have calculated earlier, that is negative 1 by 5. After substituting the value, that is v is equal to 0, and the value of k, that is, after substituting the value, that is v is equal to 0 and the value of k, we calculate the final time as 20 seconds. That means at the end of journey it should complete 20 seconds, or 20 seconds is the end point. So we have to integrate this velocity to find the distance. Between time limits of 20 and 8. So between time limits of 20 and 8, we have to integrate this. That is 1600 t cube. This is actually mentioned -2. So 1600 t to the power -2 plus 1, that is -1, by -1 minus 0.2 t to the power, as it is there is always a 1, so we have to just add 1, then divided by the total power. Then between the limits, the total distance comes to be 86.4 meter. That is, in total, the total distance of our whole journey comes to be 96 by 5, 156.6 and 86.4. That is this total distance. So this is the solution of the last question of this paper.